Hello guys, we are the group number 7 for the final project of this course, that is model and prototyping for ME2113. We worked on the engine number 9, as you can see on our slide. Our group was composed by me, that worked on the crankshaft and gear, from Logan Betts, that worked on the camshaft, Aidan Oswald, that worked on the piston head and gauge on pin, and Preston Scott, who worked on the connecting rod, and for the prototyping we worked all together. I go on my part, that is crankshaft and gear, because the gear was welded on my part. I started from the principal datum, that is the axis of the shaft, and I built the long part, extruding some circles. Then I used the semicircle to extrude the forced weight, that is the one you can see. I went on building a little thickness here, because my shaft has double thickness, and the lower part, measuring the depth and the length of the connecting part for the connecting rod. Going on, an important feature is the presence of all these holes. I have a countersink here, a key seat over there, then the hole in the middle is threaded, and on another key seat on the top. Then I gave attention to the draft angles. As you can see, they were not symmetric, so I worked them differently. Going on, I show here the revolved cut on the bottom, and then the thread, as you can see, because this part is going to be inserted in the engine and we need this thread. Then here you can see the thread on the other side and the gear. I added the gear at the end. Once it was finished, I merged the second part, and it's like this. Going on, this one was the most difficult part, because I had to use a new function, that is revolve boss base, and at the end I built it with this function, and it was pretty good with respect to the original one, because I obtained also the angles, as you can see. And I pay attention to the non-symmetric part here. In fact, as you can see, we have a lower space on the bottom than on the top part. And at the end, we have this view to see how the right part is not equal. They don't have an equal radius. Instead, we have 3 thickness, as you can see. And we just have a final isometric view to give a look to the whole part. The next part is the camshaft, which is going to be presented by Logan.
So as Mattias said, I did our camshaft, which actually differed quite a bit from most of the other teams, in that, as you can see here, most of the other teams, these are all like pretty much assemblies and different components, whereas this particular camshaft was made from the same material is actually cast all together, and it's made as a single piece, which kind of posed some new challenges. For instance, the biggest thing that's noticeable, because it was made in one piece, is if you look up here at section AA, some of these straighter parts that don't have these curves to it, especially this section here, has some pretty crazy draft angles that were pretty hard to replicate. In particular, it made it very difficult to measure with all the fillets that are around the radius there. And they also differ in length along that. Also along modeling's part, I learned quite a bit. The major thing I learned that I was not even aware that SolidWorks would do is that you can actually copy and paste bodies. As most, well not most, but some of you might know, typically you can only make gears in assembly files, which couldn't be done for this part since it was all one material. So I actually had to make this gear and then merge this in with the copy and or I guess the body move and copy function into this part file. And then this kind of highlights, even though we were told at the beginning of the project we'd have to get very creative with measurements, I wasn't exactly sure how creative we'd have to get. I in particular had to use a lot of floss to measure some of these arc lengths, like shown right here in this detail in B, just because it would sit against the part nice and flat, and I could actually mark it with a pencil to come back and measure it with a caliper to get the arc lengths. And then this next piece just shows kind of a couple more perspectives of the part. It really shows more so how this gear is attached and how it's centered and how these other pieces are offset. some of the other challenges that kind of were posed with it was having to calculate a lot of these different parts, because while you can measure a lot of this stuff in here, it's not very easy to replicate the same dimensions into SolidWorks. All right, and presenting next is Hayden presenting the piston and the gudgeon pin.
All right, so I did the piston head and the gudgeon pin. And first I'll just show you what it's going to look like in the end. We're going to start from here up. So first I just drew these semicircles and stacked them on top their desired diameters. And then to create the wall of the piston head, I just made a concentric arc and then connected to just straight lines that are offset from the edge here, the desired distance. And then I extruded that upwards, the full height of the piston head, and then I made an extrude cut to give the depth inside of the piston head. And then here, I just extruded a rectangle off that side, and then did a cut of a circle through all. And then here you see there's an angled slant. I just cut that. Okay. And then here I made these walls right here by just using a revolve feature. So that's what the inside, and once I had drawn all that, I just mirrored it to make it easier. And then you see how these are now angled, they're not square anymore. I just did a fillet on that and then created a plane on the top and sketched that semicircle rectangle figure you see right here, and then extruded it upward to make the little notch on the top. And then to create the dip of the walls, I just sketched on this flat face and made tangent arcs connected to this straight line, and then cut through all. And then over here I also there's another cut inside of that circular cut I made previously, and so I just offset those and cut it. And then as for these little rectangles, these cubes, this had already been here from that first sketch that I did, so all I had to do was measure the distances between the two and do a cut to the surface. And then there's a little shelf up at the top, and all I did was drew a rectangle and extruded outward and then did a semicircle cut. And then that's what it all comes to be like. And then as for the pin was very simple. All I did was use a revolve balls feature and just drew this figure here, the distance from the center. And then inside there's a cut, and so whenever I just drew that, I made a little protrusion that whenever revolved made the cut. And then if you put all these things in an assembly, it should just slide right on through. And now Preston will do the connecting rod.
So I did the connecting rod, and the first thing that I did was I started from the top plane and I did a mid extrude, and then I did an extrude or cut down on both sides because it's very symmetrical. And then over here I did a extrude up for the chamfer, and then I also added this little back piece to the back of it. And then this is our final view with the grates. The grates were the hardest part, and then also the little slope here. And then this is the isometric view. And then this is the small connecting piece that connects the crankshaft to the connecting rod. And then also I did an extrude of a half circle on each side, and then I did a plane on top of the small piece and extrude down. And this is like the side to show the grates of the small piece, and then also this shows like where the holes are placed, and then this is our final isometric view of the small piece. And then this is our assembly, showing that it lines up on the back, and then also all the fillets and stuff. And this just shows how it fits up correctly. And then this is our final connecting rod. And Mattia is going to do the prototyping section.
Hi guys, I'm here again for speaking about the prototyping section. In this section we work to improve the design of our connecting rod. First of all, we added some cut on the side in order to remove some materials and make our connecting rod lighter and to reduce the load and the charge on it. Then, going on, we added some materials here. As you can see, this was the original part. This is the prototype, because this section is connected with a pin and with a piston head, which is submitted to a high pressure. So we want to be safe on this zone, and we don't want a cracked here. Then we 3D printed our model, but it is still not viable. So we are going to improve our presentation with measurements and with building it on the actual motor. So you'll see the final presentation next week, guys. And that's all for today.